Alright, so let's, first of all, before we start changing anything, let's talk about kind of reasonable answers here. So again, as I read this, a baker is making cakes for a big party. She uses 1/4 of a cup of oil for each cake. How many cakes can she make if she has a bottle of oil that has 6 cups in it? Now, this means, again, I use 1/4 cup of oil, and we have a total of 6 cups. So are we going to be able to make a cake? We're going to be able to make 5 cakes? Or are we not even going to be able to make a cake? What's that? We're going to make a bunch of cakes. I only need 1/4 of a cup. And we have 6 cups. If all you need is 1/4 of a cup and you have 6 cups of oil, you can make a lot of cakes. So some of us, as I walked around, you had a fraction. The common answer I saw as I walked around was 1/24. What that means is that you're making 1/24 of a cake. You're not even making a whole cake. That answer to me doesn't quite seem reasonable. Because all I need is 1/4 cup. And I'm already making 1 cake. And I definitely have 1/4 cup if I have a total of 6 cups. Now, my suggestion that I gave you yesterday is the suggestion I'm again going to give you today. Get rid of the fraction. There's only one fraction in this problem. Get rid of it, make it a whole number, and ask yourself, what would this problem be if blank? So let's do this a couple different times. What if I told you this, and this is a lot of oil, but let's say that we're going to use a cup of oil. Okay? If we have 6 cups of oil, and each cake takes 1 cup, how many cakes is this baker going to be able to make, Bryce?
6.
He's going to be able to make 6 of them. And how did you get that, Bryce? What's the operation we did?
First, simply, I don't know, just for a hypothetical situation, let's say that we have 1 cake, with icing and all, with strawberry seeds,
Okay,
and all
yep.
all the stuff.
Just tell me how you did it, though. Did you add, subtract, multiply, or divide?
I think that you probably would have, how I always did it is personally, that's first simply you just,
Because we didn't add 6 and 1,
no,
right?
we didn't add 6,
Did you multiply them? Did you divide them? What were you thinking of doing?
division.
Division.
Yes.
And what we did was you took 6 divided by 1, and you got an answer of 6. If each cup or each cake takes a cup of oil, 6 divided by 1 is 6. Now you might say, well, Mr. Tompkins, 6 times 1 is 6 as well. I agree with that. So let's change this number one other time. Let's say that it takes 2 cups. If I take 2 cups of oil to make 1 cake, and I have 6 cups of oil to use, how many cakes can we make? 3. How'd you get 3?
Divided. How many times
What by what?
goes into 6?
Okay, so you took 6 and you divided by 2 to get 3. Does everybody see the pattern that we're doing here? Okay? So now, here's what I know. I know I'm doing a division problem, and the order of division matters. I also know that in every one of these problems, I'm taking the total amount of oil we have, and I'm dividing it by how much oil I need per cake. So now let's just repeat that process. We're going to take how much oil we have, which is 6, and we're going to divide it by how much I need per cake. How much oil do I need per cake? I need 1/4. This is what the question's ultimately asking us to do. Now, what's the rule that we talked about? There's a 3-word phrase that we talked about yesterday when we divide by fractions. What is it? Keep, change, flip. Now, first of all, what do we do with a number if it's not a fraction and we're trying to work with fractions? You put it over 1. So our keep, change, flip would tell us we're going to keep the first fraction as 6 over 1. We're going to change the division into multiplication. And we're going to flip the fraction and make it 4 over 1. Who remembers what the phrase or the word that we talked about yesterday? When I flip my fraction, I'm talking about the what? Talking about the reciprocal. Now we're back to a multiplying fraction problem. What's the rule when we multiply fractions? multiply straight across. So we'd have 6 times 4, which is 24. And we'd have 1 times 1, which is 1. Remember that we're not going to write a problem as a fraction or an answer as a fraction unless it's required. This one's not required. So my final answer to this problem is 24 cakes.
That's a cake.
Well, it's a big party. She's a baker. All right, now, here's another way that I might also think about it. I know that if I were to take a fourth of a cup, a fourth of a cup, a fourth of a cup, and a fourth of a cup, and I added this all together, how much oil is actually being used right here? 1 full cup. Now, how many cakes does this addition problem represent? 4 cakes. So another way to think about this problem is it takes 4 cakes to use a cup of oil. Well, if it takes 4 cakes to use a cup of oil, how many is it going to take to use 6 cups of oil? 24, because 4 times 6 is 24. Okay, so you've got a couple different ways to kind of be able to approach this problem. My strategy that I really push to students is this one here. Recognize the pattern. What's the operation I'm doing with whole numbers? Now repeat that same operation in the same order, but get rid of my whole numbers and put the fractions back into play. All right, here is problem number 2. Again, if you don't know what to do, don't just start with don't start with these numbers. Replace the numbers with nice numbers that you like, ask what you're going to do, and then repeat this process. So let's start talking about this one, and again, I'm going to talk about reasonable answers, first of all, okay? There is 13 cups of granola in a container, and each serving is 3/4 of a cup. So that's not even 1 cup will make 1 serving. I know right off the bat, there's got to be more than 13 servings in this particular container. Does that make sense on how I got that? If each serving was 1 cup, there would be exactly 13 servings in this particular problem. The fact that each serving is less than a cup means there's more than 13 servings in my answer here. So my answer to this problem, whatever it is, has got to be a number that's bigger than 13. Now again, let's think about what we're going to do. Now I'm actually going to change, even though this is already a whole number, I'm going to change it to a number that's not prime. So right now, let's do this. Let's say I've got 15 cups in there. And each serving was 1 cup. How many servings are in this particular container? 15. What if there's 3 cups in a serving? How many different servings are now in this container? 5. What if I made this to 5 cups? There would be 3. What are we doing with these numbers? Are we adding, subtracting, multiplying, or dividing? Okay. What by what?
13 divided by.
Well, let's use the numbers I have here, though. We took 15 divided by 1 to get 15. We took 15 divided by 3 to get 5. We took 15 divided by 5 to get 3. If this is what I'm doing with my whole numbers, then doing this with my fractions should be the same idea. So now we're going to get rid of the 15, we're going to get rid of the 1 and the 5 and the 3, and we're going to go back to this problem as it is. So if I'm going to continue this process, what am I actually doing in this problem? We're doing what divided by what? 13 divided by 3/4. Okay, again, we're going to use our keep, change, flip, and as we use our keep, change, flip, we're going to make sure that we change this whole number into an improper fraction. So we're going to make that into 13/1. We're going to change division to multiplication, and we're going to flip our second fraction to become 4/3. So, again, when I go to multiply fractions, what are we doing? We're multiply straight across. So we're taking 13 times 4, which is 52, and 3 times 1, which is 3. Now again, I'm completely fine with this as my final answer. This is right. But also just to kind of give a context to it. How many times does 3 go into 52? 17 times with a remainder of? Not a big remainder.
1/3.
1 with a remainder of 1. So really what we're saying is there are 17 1/3 servings in this particular package, which makes sense. Because we said that if it was a cup per serving, there would be exactly 13 servings. We said there needs to be more than 13 servings. This number is more than 13 servings. You can have 17 servings, and you've got 1/3 of one left over. Alright, so yesterday we did multiplication, today we did division. Again, we're going to kind of be looking at it and throwing in all operations through these, but we've really got to be careful with fractions. Make sure we're doing the right operation. Make sure that we are doing them in the correct order. Those are the big things we're looking for. Alright, let's go ahead then and take a look at the assignment from last night. did through 27, didn't I?
Yeah.
Okay. I don't know why I didn't. Since you can't see 27 on there, I'll just write it over here on the side. This is a negative 8 over 189. Alright, let's go ahead and start taking a look. 7 through 27 odds. Any of these that we'd like to talk about? Come on. Okay, problem number 7. Alright, so in problem number 7, we are given 8 over 11 divided by the fraction of 33 over 40. Alright, I'm going to caution you right now because this is a mistake that I've seen people make in previous years. You can't reduce here. Even though people are like, well, I want to because I want to make my number smaller. The only time that you can work on reducing is if it's already turned into a multiplication problem. So you can't reduce your 8 and 40, your 11 and 33. So if we use our keep, change, flip, keep the first fraction, change division to multiplication, flip the second fraction to be 40 over 33. And actually what you find out is you can't reduce any of these. 8 and 11 can't be reduced, 40 and 33 can't be reduced, 8 and 33 can't be reduced, 40 and 11 can't be reduced. So, the only thing left is for us to multiply those together. 8 times 40 is 320, 11 times 33, 330 plus 33 would be 363. That answer is reduced. Okay, number 23. Alright, number 23 gives us a negative 1 and 17/55, and this is being divided by 1 and 11/70. Alright, first thing we need to do with these mixed numbers is change them to impropers, then we'll use the keep, change, flip. So, negative number, remember to ignore the negative to begin with. 55 times 1 is 55. We add 17, and we should have 72 over 55. Then we'll bring the negative back into that. This is being still divided by, I'm not keep changing, flipping yet, I'm just changing to impropers. 70 times 1 is 70, plus 11 is 81, so 81 over 70. Now I can go ahead and use my keep, change, flip. So this problem, when I use keep, change, flip, will become negative 72 over 55. We change division to multiplication, and it's 70 over 81. Now, this is not a problem, I'll be honest, that I would just go ahead and multiply. Okay? You're going to get some really large numbers really quickly, and you've got a lot of reducing that you'd have to do at the end. Somebody tell me a factor that we see is going to go into a number on top and bottom, Miles. 5. Right here, these two numbers are divisible by 5. So if I take 55 divided by 5, that gives me 11. If I take 70 divided by 5, that gives us 14. Any other factors that I can divide out here? 72 and 81 are both divisible by 9. So negative 72 divided by 9 is negative 8. 81 divided by 9 is 9. Now, I'm still going to look at it. 8 and 11, those can't be reduced. 14 and 9 cannot be. 11 and 14 can't be, and 8 and 9 can't be. So my final answer when I multiply here, everything is going to be reduced. So, when I multiply negative 8 times 14, that should leave me with a negative 112. And 11 times 9 is going to be 99. Now, if you would have multiplied this entire thing out, somebody tell me, what did you get? What's negative 72 times 70? And on the bottom, we'd have what? What's 55 times 81? 4,400 what, Caitlin? 55. Do we see why it's not a real good idea to multiply right away? Now, you're going to look at this and say, well, this ends in a 0, this ends in a 5, so they're both divisible by 5. That's great. But then you'd still have to take that and divide them each by 7. Sorry, divide them each by 9. Okay? So, again, I'm going to continue to emphasize, keep the numbers small by trying to reduce first. But, a reminder again, you can't reduce until you've changed it to a multiplication problem. If it's already a multiplication problem, awesome. And remember, today's assessment is a mixture of all of this. So you need to know, what do I do when I multiply? What do I do when I divide? Make sure that it is not until you're multiplying that you go to reduce your numbers. All right. Number 25. Number 25, we have a whole number being divided by a fraction. So we've got 27, and this is being divided by a negative 3/11. All right, so we're going to go ahead and change this into a fraction so we can use our keep, change, flip rule. So we'll keep 27 over 1, change division to multiplication, and we're going to flip this. Now, with the negative fraction, you can put it with the 3 right away, then move it to the bottom and make it a negative 3. Or you can put it with the bottom and make it a negative 11, and then when you flip it, the negative's on the top. I really don't care. Because we should know that a negative or positive divided by a negative is a negative. Our answer's got to be negative here. Now, I'm going to do some reducing, because what's the common factor we have here? 3. 27 divided by 3 is 9. 3 divided by 3 is 1. Now, when I go to multiply straight across, 9 times negative 11 is negative 99. 1 times 1 is 1. This number does not need to be written as a fraction because it just becomes a whole number. So we're left with a negative 99. All right, next one, Maya. 27. All right, for problem number 27, we had the fraction of negative 16 over 21, and this is being divided by the whole number of 18. Again, if we're going to use the keep, change, flip, let's go ahead and change this into a fraction. So now, when we go to do this, we're taking negative 16 over 21, change division to multiplication, flip the 18 over 1 to 1 over 18. Any common factors here? 16 and 18 are both divisible by, I heard somebody say it, both by 2. Negative 16 divided by 2 is negative 8. 18 divided by 2 is 9. Okay, anything else? No. So now when I go to multiply, negative 8 times 1 is negative 8 over 21 times 9 turns out to be 189. That is my final answer. All right, I saw another hand here. Chloe, number 13. We're taking 3/13 and we're dividing this by 15. All right, Again, we're going to throw this into a fraction so then we can use our keep, change, flip rules. Again, point this out. Well, you couldn't do any reducing here, that's fine anyways. So, keep, change, flip.
You can't do it.
Alright, do I have any common factors now that I've done my keep, change, flip? Two numbers that are divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Now when I go to multiply across, I've got 1 times 1, which is 1, over 13 times 5, which is 65. My answer becomes 1/65. If you multiplied right away, that's fine. You would have gotten 1 over, what, like 195? Or sorry, 3 over 195. Then you got to divide everything by 3. Okay? Delaney,
21.
number 21. 21 says we've got 6 and 6/13. This is being divided by 2 and 28/39. Alright, so again, let's get these changed into impropers first. I'm going to want somebody to double check my math here, but 13 times 6 is 78, plus 6 would be 84 over 13. 78 plus 28 is 98, so 106.
Yeah.
Yes, over 39.
Yes.
All right. Again, we're not changing this to a multiplication problem, and that's sometimes, again, a common error. People will think, well, I've done my keep, change, flip, I need to change this to multiplication. No. All I've done is I've rewritten this problem using improper fractions. That's it. Now, we can do our keep, change, flip. 84 over 13 multiplied by 39 over 106. Now, this one might not be quite as easy to recognize, but 13 and 39 each have a common factor. Even though 13 is prime,
13.
these have a common factor of 13. 13 divided by 13 is 1. 39 divided by 13 is 3. 84 and 106, they're both even, correct? So they're both divisible by 2. This becomes 42. This becomes 53. Okay? And then actually that's it. That's all my common factors. 42 times 3 should be 126. Over 1 times 53 is just 53. There is the final answer. Again, you may be doing these by multiplying first, reducing second. I'm not going to be picking on today's assessment. I'm just showing you this because, again, I think the more you get exposed to it, the easier it's going to be for you to be able to do. Okay? I do want to give you kudos. This is a great job of asking questions this morning. Okay? This is what we need if we know that we're struggling with any of these concepts. When we come back in during 7th period today, we will take our assessment. It is not going to take us 40 minutes, so we'll probably do some quick review, then take your assessment and wrap up, and then tomorrow we might